So the solution to this takes a little bit of work, but it's not that difficult. So let's draw a nice big drawing of our problem so we can work with that. So here is my sector. I'm going to draw a little more straight. Here's my sector. So now if this is theta, then this, and this is r, then this right here is r cosine theta, and this is r sine theta. So that's a good thing to establish. So the area of this triangle right here is going to be base times height divided by 2. So it's going to be r squared sine theta cosine theta over 2. So that's to note first. Now the area of this large triangle right here, so this one, the one that goes like this, that triangle, is same. It's going to be base times height over 2. So now the base is going to be r, because it's the full length, and the height is still r sine theta. So we're going to have, it's going to be r squared times sine theta over 2. Now, if we take this minus this, we're going to get just this small triangle. So we'll do that at this point. So r squared sine theta over 2 minus r squared sine theta cosine theta over 2. We can write it pretty compactly, and we can just write r squared sine theta times 1 minus cosine theta all over 2. And that will give us that is our b of theta. So now let's work towards finding, let's write that result up here, keep it, so r squared sine theta times 1 minus cosine theta over 2. So we're going to keep that result up there, and then we'll solve for a of theta. So a of theta is given by, if we shade our arc right here, then the area of the whole piece is given by 1/2 r squared theta, because that's how you define a sector area. And from that, we have to subtract the area of that big triangle. So from that, we subtract r squared sine of theta over 2. So we just factor, and we get r squared times theta minus sine of theta all over 2. Yeah. Then that's going to be our A, and that's our B. So now we just have a matter of division. So it's going to be, these r squared will cancel out, these 2 will cancel out, and we're just going to get theta minus sine of theta over sine of theta times 1 minus cosine theta. And that is the expression for A of theta over B of theta. So now that we have that, everything else is just going to be calculus and algebra. We don't have any more geometry calculations to do. So now that we have that, we need to take the limit as theta approaches 0 from the right. So if we just plug in 0 everywhere, we get theta is 0 and sine of 0 is 0, sine of 0 is 0, and 1 minus 1. That's going to give us 0 over 0. So we're going to get indeterminate form. So by L'Hopital's rule, we're allowed to take the derivatives of the top and bottom to help us. So the derivative of the top is going to be, so we're going to take A prime theta over B prime theta. And that's going to give us 1 minus cosine of theta all over, so I'm going to split this up into sine theta minus sine theta cosine theta. So we're going to get cosine theta minus, it's going to be cosine squared theta minus sine squared theta. So now that we have that, we can erase this. And if we try to take that limit, we get, if we plug 0 into here, we get 1 minus 1 over cosine theta is 1 minus cosine theta is 1 minus 0, and that's still 0 over 0, which is an indeterminate form, so we can't use that either. So we are allowed to use L'Hopital's rule once again to try to help us. So if we do that once again, we're going to get negative sine of theta, or we're going to get positive sine of theta rather, over negative sine of theta minus 2 cosine theta sine theta minus another 2 sine theta cosine theta. And this is going to be in enclosed. So cosine theta and this is going to be negative right here. So really this is all going to be positive. It's all going to go positive, and we're going to get 4 cosine theta sine theta because we add these two, and so we have this. And if we try to, this is going to be positive. So if we try to put 0 into here, we're going to get sine of 0 0 over 0 again. So let's use L'Hopital's rule one more time to try to solve this, and we will get to our answer. So we're going to take one more time, and I'm going to do this up here. So we're going to get cosine of theta all over. So we're going to get negative sine theta gives us negative cosine theta plus, and this 4 cosine theta sine theta can be compactly written by a double angle identity as 2 sine 2 theta. So we're going to get 2 cosine 2 theta times, well, it's going to be negative sine. 2 cosine 2 theta times 2, so it's going to give us 4 cosine 2 theta. And now what we have to do is plug in 0 into there, and we're going to get 1 over negative 1 plus 4. So it's 1 over 3, and that is the final answer after repeated L'Hopital's rules.